Good afternoon. I'm going to be starting Unit 9, Lesson 1. I'm going to go over some of the guided practice and independent practice to help you get through some of the problems. I'm also going to go over key information that will help you understand classifying different types of parallelograms. So let's begin. So we are on Unit 9, Lesson 1. This is the guided practice. We're going to go over problems number 2 and 4. So this is from page 807. That's the guided practice. So there's a problem number 2 where we have a parallelogram. And the problem wants you to solve for each variable in the parallelogram. So if we look, the variable that we're going to be solving is x. And so on page 803 in your textbook, there is 4 theorems that classify a parallelogram that I would like you to pay attention to. One of those theorems has to do with problem 2, where it says that the opposite angles in a parallelogram are congruent. So this angle up here, if we have R, Q, P, and S, angle Q would be congruent to angle S, and angle R would be congruent to angle P. So this means that Q and S are the same angle, and R and P are the same angle. So over here, we know that angle Q is equal to 12x minus 19, and angle S is equal to 125 degrees. And because they are equal, angle Q is congruent to angle S. That's one of the theorems from page 803 on parallelograms. We're going to set them equal to each other. So we're going to have 12x minus 19 equals 125. We're going to add 19 to both sides of the equation to get x on one side of the equal sign, and that's going to equal 144. So 12x equals 144, and we're trying to solve for x, so we divide both sides by 12. X equals 144 divided by 12, which is 12. So we just solved for the variable x. And now we are going to work on problem number 3. So problem number 3, we have a parallelogram just like this, and it is labeled as J, M, L, and K. And we have side JK is 15, KL would be 3Z plus 1, KM is 22, and ML is not labeled. So this brings us to another theorem of parallelograms from page 803 that I want you to pay close attention to. So essentially, if we have another parallelogram, and I'm just going to label it the same as the one we're looking at, so I'll just say JK, M, and L. We have a theorem that says that the opposite sides of a parallelogram are congruent. So that means that side JK is congruent to side ML, and side JM is congruent to side KL. So knowing that, we're trying to solve for the variable z right here. Now if we look, the opposite side, these two sides are congruent. So we're going to set 3z plus 1 equals 22 We're going to subtract 1 to both sides, and we get 3z equals 21. And finally, since we have 3z equals 21, we're going to divide both sides by 3. Z is going to equal 21 divided by 3, which means z is equal to 7. So the key components that I want you to remember is that when you're looking at different types of parallelograms, the opposite angles are congruent. That's one of the theorems. The opposite angles are congruent and the opposite sides are congruent to one another. So therefore, if you know two opposite angles and there's a variable, you can use algebra by setting these angles equal to each other like we did and solve. Or if you have two opposite sides, you can set them equal to each other if there's a variable and you're trying to solve for a variable on one of the sides, and then basically use algebra to find the variable just like we did. All right, so we're going to move on to problem 4 of the guided practice. And then we'll begin the independent practice. So problem 4 is another type of parallelogram that we have to look to solve. So we have this parallelogram FGHD.